What does the sign of the gradient indicate? The sign of the gradient tells us very important information about the slope. We have the following cases when dealing with gradients. 1. If the gradient is a positive finite number, the line increases in the quote, the line is increasing, when shifting from left to right. When dealing with linear graphs, it is always possible to identify two distinct points with different coordinates, as we did in the first line of the example. As always, we take the leftmost point as the first point to use in the gradient formula. We use the uppercase letters of the alphabet to express any points, so if for example, a certain line contains 2 points B and B, then point A is the leftmost one. As stated earlier, the gradient value tells us how much faster, or slower, the y-coordinate increases with respect to the x-coordinate when shifting from left to right on a line. Thus, if the gradient is greater than 1, the y-coordinates increase faster than the corresponding x-coordinates. If the gradient is equal to 1, the y-coordinates increase at the same rate as the corresponding x-coordinates. And if the gradient is smaller than 1, the y-coordinates increase slower than the corresponding x-coordinates. We have the following shown on screen. The gradient of the line shown in the graph is 2, because it is evident that the y-coordinate increases twice as faster than the corresponding x-coordinate. Thus, the y-coordinate from 1 becomes 3 when shifting from A to B, while the x-coordinate from 0 becomes 1 during the same process. On the other hand, the gradient of the other line shown in the figure below is 1/2, or 0.5, as the y-coordinate increases twice as slow as the corresponding x-coordinate. We have the following shown on screen. Thus, the y-coordinate from 2 becomes 3, increases by 1, while the corresponding x-coordinate increases from 0 to 2, increases by 2, when moving from A to B, 2. If the gradient is negative, the line decreases in the quote, is decreasing, when shifting from left to right. If the gradient is smaller than -1, then the y-coordinate decreases at a higher rate than the increase in the corresponding x-coordinate, as shown in the figure. We have the following shown on screen. You can see that for every 1 unit of increase in the x-coordinate of the line, there is a decrease by 3 units in the corresponding y-coordinate. Therefore, we say the gradient is -3, as the y-coordinate decreases 3 times faster than the increase of the x-coordinate. Indeed, using the gradient formula for points A and B of the line yields, we have the following shown on screen. On the other hand, when the y-coordinate of a line decreases at a slower rate than the increase in the corresponding x-coordinate, we have a negative gradient greater than -1. The following figure represents such an example. We have the following shown on screen. From this graph, it is obvious that for every 8 units of increase in the x-coordinate there are 2 units of decrease in the corresponding y-coordinate. Therefore, the gradient of this line is -2/8, or -1/4, or -0.25. Indeed, using the gradient formula for points A and B of the line yields, we have the following shown on screen. Remark: the change in the x-coordinate is always taken as positive, as we always consider movements from left to right. The sign of the gradient is therefore determined by the changes in the y-coordinate. Moving up equals positive, moving down equals negative. What if the gradient is equal to -1? Well, in this case, any increase in the x-coordinate brings a decrease in the same rate of the corresponding y-coordinate. Look at the figure. We have the following shown on screen. Indeed, using the gradient formula for points A and B of the line yields, we have the following shown on screen. Example: find the gradients of the following lines shown in the figure shown in the following on screen. Solution: The procedure for calculating the gradient of the shown lines requires identifying two distinct points for each line. In this way, we obtain the following figure shown on screen. A. For the line 1, we have to consider the points A, -3, 1/5, and B, 0, -1, to calculate the gradient K, 1. Thus, using the gradient's formula yields, we have the following shown on screen. B. For the line 2, we have to consider the points C, 0, 1, and E, 2, -1, to calculate the gradient K2. Thus, using the gradient's formula yields, we have the following shown on screen. C. For the line 3, we have to consider the points C, 0, 1, and D, 1, -2, to calculate the gradient K3. Thus, using the gradient's formula yields, we have the following shown on screen. As you see, all the gradients are negative, as expected, because all the three lines are decreasing when moving from left to right. That is all for lesson 14.2.2. To continue this tutorial, please watch 14.2.3. What is the gradient of a horizontal and a vertical line? Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.